Hey guys, this is Mrs. Tran-bloom. I'm just kind of having some issues with my recording. Hopefully it's not going to be on this one. We're like about 8 minutes down. My voice will kind of, it goes quicker than my writing. So I'm not sure how to fix that. At this point I kind of don't know what to do. So hopefully this video, it didn't do it before when I was recording at home, which where I am at right now. But all of a sudden it's now doing it, so I don't know what's wrong. So I'm trying out this video and hopefully it works, okay? So 5.3, exponential functions. This is really important, alright? There are some vocabulary and some theorems that we're going to talk about. Super important vocabulary and theorems. So first, law of exponent theorem. Law of exponents. If S, T, and A, and also B are real numbers. Remember, real numbers are pretty much everything you can think of except imaginary. With A being greater, which is positive, okay, and B being greater, which is also positive. So A is positive as well as B, okay, and also B. Then here are the rules from Algebra 2. Okay, you have to remember these rules already. I'm not teaching you something that you've already learned, but I'm just going to review this with you. When you have A to the S power times A to the T power, because the two bases are exactly the same, we add the exponents. Okay, A to the S raised to the power of T, power to the power, we would multiply the two powers. A times B to the S power, we can actually distribute the S. So it becomes A to the S times B to the S. Okay. We are not going to add the S's because base A and base B are not identical. 1 to any exponent equals itself. A to the negative exponent becomes 1 over A to the positive exponent, or 1 over A to the positive exponent, because as you remember from the previous rule here, 1 to any power is itself. So 1 over A to the S is identical to 1 over A to all of it to the power of S. A to the 0, it's always 1. Okay, so you can have 1 million to the 0 power. That will always give you 1. Alright, next law. Exponential function. An exponential function is a function of the form f of x equals c times a to the x, where a is a positive real number, which is greater than 0, and a can never ever be 1. C can never ever be 0, okay? And it's also a real number. So all of these just talk about in real number. The domain of f is the set of all real numbers. So that means this is really important. Anytime you see an exponential function, the domain, it's always all reals. So you don't even have to think about it. The base A is a growth factor, okay? Well, we're going to talk about the growth factor or decay. And because f of 0 equals, this is your input, equals the initial value times your base to the 0 power, A to any number to the 0 power, it's always going to be 1. 1 times c is c. We call c the initial value. Okay, so a couple examples would be, so i.e. f of x equals 2 times 3 to the x power. This is the growth equation. It's a growth equation because the larger x I substitute in, for example, if x is 1, 3 to the 1 is going to be 3. 3 times 2 is 6. If I substitute 2 in for x, 3 to the second is 9. 9 times 2 is 18. As you can tell, if x is getting larger, then this is a growth factor. Now what happens if x is going to be negative? Okay, so if x is negative 1, then you would have 2 times 3 to the negative 1, which is by definition 2 times 1 over 3. Oops, you can't see that. This is now 2 over 3, okay, which is smaller. How about when x is negative 2? Then I would have 2 times 3 to the negative 2 equals 3 to the negative 2 by definition previously stated is 1 over 3 to the second. So that's 3 to the second is 1/9. 1/9 times 2 is 2 over 9. Okay? Which is getting smaller. So when x is negative, this function is actually a decreasing or decaying function. But when x is positive, then you have an increasing function. Okay? Alright, e, an awesome looking number, right? The number e is defined as a number, the expression 1 plus 1 over n to the nth power, as n approaches a really large number, infinity. In calculus, this is expressed using limit notation as e equals the limits of n approaches infinity. Okay, so e equals the limits of 1 plus 1 over n to the nth power as n approaches infinity. Okay, so as n approaches a really large number, then this equation here becomes closer and closer and closer to e. Alright, so what I would like for you to do right now is, I would like for you to use a calculator. Okay, so in your notes, use your calculator and find the E button. Find E button. Okay, and I would like for you to write 2 locations where your E button is. So when I check your notes, I need to see these. Okay, go and find your E button. Alright, now that I need to go get my calculator, hopefully you guys have written down where the 2 locations are. Okay. If you need extra help, I can point you to the location. The first location is, let me move it up, is this ln button. Can you see that right there? This is ln button. So the inverse of ln, it's e to the x. So it's under log, which is, let's see, 1, 2, 3, 4, 5, 6. So 7, the 7th button down on the right, on the left. This other button, it's actually here underneath pi. So it's the 3rd button down from the right. Okay, so those are your 2 locations. Well, you can write in those. Okay, so example 1. Using a calculator, evaluate. So what I'm going to do is I'm going to do A and let's see, A and E with you, alright? And then your job is to use your calculator to do the rest. And if you're faster than me, you can do all of them on your own. So here we go. Using the calculator, evaluate 2 to the power 1.4. So 2, I'm going to enter 2, okay, caret 1.4. Equals, I would like you to round that to, you know what, don't round. Write it all out for me. Okay, yes, I asked you to write it all out. Here we go. 2.639015822. So that's what we get for 2 to the 1.4 power. So now I'm going to do E. So let's do 2 caret square root of 2. Gives me 2.665144143. Okay, so do me a favor. Your job is to complete B, C, and D. So pause it right now for me. Pause it, pause it, pause it, and then finish those. Okay, so these are now on your own.